10 o'clock class, I did some more examples of graphical methods for finding where the two meet at the 10 o'clock class. And we also did another Gaussian example. So if you watch the second tutorial video that's in the playlist, you can jump to the middle of the video if you want to and have a look at that. Okay, so next lesson now. We're going to have a look at something called surds. And surds are things in this form: a plus b root c. And usually, or well, not usually, sorry, I should say, sometimes the a could be 0, that's fine. But usually the b is the one that's not 0, or the c as well is not 0. Anyway, these are called surds. So let's have a look here. Now, the first thing we want to have a look at is how we can simplify surds. So some of them can't be simplified. Some of them obviously can. This one is easy. But then, we might get something like this, which can be simplified 3 root 10. But the question is how. So we'll look at the method now for simplifying this, okay? And it uses something called prime factorization is the method. So let's have a look at how this works. So no, easy peasy, but this one here is a little bit harder. Okay. Can I scroll down? Yeah? Yeah? Right, so let's say I want to simplify something like square root 245. Now it's a little bit tricky, and you can do this in your head, but if you need a little help, how can we approach it? So we do something called prime factorizing. You take your 245 and you write it as a multiplication of two numbers. Any two numbers except 1. So obviously 245 and 1 is not really useful. Okay, so we look at this and we say, alright, well maybe I'll go with 5 and 49. If you think of any two numbers that multiply to make 245, how did I know that 5 is possible here? Because it ends in a 5. So I knew that it must have been a multiplication of 5. So it's 5 times 49 makes this. Okay. Can we simplify the 5 anymore? No. Okay. But the 49 we can. Yeah. 7 squared. So what you can do is you can change root 245 into 5 times 7 times 7. Or to be a little bit clearer, you can change it to 5 root 7 times 7. Now this form is very nice, because what does this become? 7. Because 7 by 7 is 49, and the square root of 49 is 7. So when you have something nice like this, you can see that this must be a 7. So this has to be then 7 square root 5. Yeah, 7 root 5. Alright, let's do another example. Let's do a bigger number. Can I scroll down?
Yeah.
Right. Root 840. Okay. What's the obvious multiplication here? 10 and 84 would be the obvious one. 10 is obviously 2 times 5, and we have to stop. Okay, we could go with a 4 and a 21 here. The 4 could go down to 2 and a 2. The 21 could go down to... Yeah. Okay, now we have it all finished here. So I can change root 840 into root 2 times 2 times 2 times 3 times 5 times 7. Did I get them all? 2, 2, 2, 3, 5, 7. Yeah. Which I could write as square root 2 times 2, square root 2, 3, 5, 7. Now, this one is nice. What does this become? 2. But nothing here. So I might as well just multiply them together to write as a single number. 6 times 5 is 210? Yeah. So 2 root 210 is the best I can do here for this one. Yeah. Type in root 840 on the Casio there. It should give it out as a... Right, okay, so that's the basics. Let's continue now. Can I scroll down? Yep. No? Okay. Scroll down. Now, just before I continue, important. Root AB does equal root A root B. Okay? Root A over B, root A over root B. Root A plus B, not root A plus root B. And likewise for minus then, okay? Don't do that. So root 3 plus 2 is not root 3 plus root 2. Okay, you can't do that. Okay, so let's continue now. So let's say I had something like root 490 plus root 10, and I wanted to simplify that. Well, let's do what I did in the last example. Let's try and simplify each of them. So 490 is obviously 49 and 10, which is 7, 7, and 10 is 5 and 2. And 10 is also 5 and 2. So this could be root 7 times 7 times 5 times 2, plus 10 is 5 times 2. So what does this part become? 7 root 5 times 2, which is 10, plus root 10. Yeah, because it's like a 1 here. So 7 root 10 plus 1 root 10, 8 root 10. Yeah? Yeah. Okay, so write this one down. We'll go on to harder ones now. Got this? Let me scroll down. Now, before I go on, let me actually just give you guys one to practice. I just want you to try this one for me. Oh, that's too easy. Yeah. Root 728 minus root 182. Just give this one a quick try, just to make sure you're getting the idea here. Without the calculator. Rots the brain if you use it too much. Use what? Oh, this method? Nah, try without the calculator. It's good. It's good mental exercise. No calculator. I want you to try this without the calculator. No, try without the calculator. It's good mental exercise. Yeah. Let's have a look here. So, look, 728. Obviously, it's a 2 because it's an even number. So that'd be, what would that be? 364. Okay. That's also even.
Yeah, so another 2.
Another 2 can go in here.
114.
And then 1. Now don't give me 2 answers, okay? 18 or 19?
182.
Correct. Now 182. 2 and 91. Good. 91? That's the end of it, isn't it? None goes into 91. Okay, and then 182 is 2 and 91, isn't it? So this will be square root 2 91 minus square root 2 91. So that would be 2 square root 182 minus 1 square root 182. So that's right, isn't it? Yeah, so just root 182. And that's it there for this one. I mean, they're not super easy. You have to think, and I know thinking is hard. So we'll go on to something else now.
Can you just divide it by 7 in the first step?
7.
And 104.
No, wait.
What?
7.
104.
Yeah, no, you're right. Yeah, 7. No, hang on.
7 times 108.
104, is it?
104. Oh yeah, no. Yeah, absolutely.
Yeah, but I'm confused because if 7 goes into this, then why didn't I get a 7 here somewhere? 7 doesn't go into 91, does it?
No, it does go into
7 does go into 91.
Yeah, 7 and
So actually, it's possible that my answer of root 182, it's possible my answer of 182 could be simplified. Yeah, so 182 is 291, and 91 is 7. Yeah, okay. There was no advantage of continuing the process.
Because there is no perfect root from dividing 182.
Yeah, you can't get any perfect squares out of 182. We can get a 2, a 7, and a 13, but that's no good to us. Yeah. So we can leave it as root 182. Yeah. So if you went with 7 at the start, that's fine as well. You'll get the same answer in the end. That's what's good about this method, is that it doesn't matter which multiplications you pick at the start. It should still work out in the end. Okay? Right, next now. So what I want to do next is, if we have a multiplication like this, now the good news here is the usual rule still works. You can still do first by first, first by second, second by first, second by second. But before I do that, I just want to make sure I can't simplify anything. So let's just have a look here. 15 is 3 and 5. Would there be any point in doing that? No. 18 is 9 and 2. Well, I don't know, because 9 is 3 and 3. So I think I will. Yeah, I will change this into 3 root 2. 2, any good? No. What about 135?
It's
5 and 61? No, what am I saying? Sorry,
23.
23?
No. 27, yeah, 27.
27, yeah.
Which is
Oh, so, and that's
9 and 3.
a 9 and 3. So I can change this into 3 root 15. And now you can see why that looks a little bit better. Because it's similar form. You know? 15, 15. 2, 2. So let's multiply. 3 root 15 by root 15, what do I get? I get 3 times 15, which is 45. 3 root 15 minus 3 root 2 will be minus 6 root 30. Because 9 root 30. 3 by 3 and I've lost track of which one I'm multiplying. This one by this one. So 3 by 3 is 9, and root 15 by root 2, root 30. Okay. Minus root 2 by root 15, minus root 30. And then lastly, minus root 2 by minus 3 root 2 is plus 3 times 2. So 6 then, isn't it?
Yes.
So I get 51 minus 10 root 30. Alright, it's not very easy, not very easy. So once you write that down, I think I should have you try one. So I want you to try root 24 plus root 5 times root 6 plus root 20. So that's a 6, and that's a 24, 5, and 20. Once you write that down, try that example. See if you can get it. Okay, nearly finished this. As much as you can. As much as you can. Okay. Let's before we start, let's see what we're dealing with here. 24, that's 12 and 2, 6 and 4, what am I saying? 6 and 2, and 2, 3 and 2, and the 2 and the 2. So I can change 24 into 2 root 6 plus root 5. Root 6 plus 2 root 5. Yeah? Yep. Right, multiplying that out. 2 root 6 by root 6 would be 12. 2 root 6 by 2 root 5 is 4 root 30. plus root 30 plus 10. 22 plus 5 root 30. That's as simple as it's going to get. By the way, on the Casio calculator, if you were to type this question in, would it actually give you the answer? Let's have a look. If you've got a graphing calculator, dude. Let's check. Now in the exam, of course, if they ask you to do this, you have to show your work, but you can at least check your answer on the calculator. So why don't will everybody just take a minute to see what happens if they type this question in on their calculator? Will the calculator give this as the answer? Yeah, nice. Nice. So you can at least check the answer. Here we go, let's have a look. Root 24 plus root 5, root 6 plus root 20. There you go. So in the exam you will know if you got this right. Okay. Right, so now on to the last type of surd problem, which is, it's a bit tricky. It's when we divide. So let's have a look here. Can I scroll down? Minus 63 plus root 504 over minus 7 minus root 14. Now that's not an easy one to do. There's a trick here called rationalizing the denominator. And we have to make use of something called the conjugate. Or before that even. If I have 2 plus root 3, its conjugate is 2 minus root 3. Or if I had, 2 minus root 10, its conjugate would be 2 plus root 10 then. Minus root 2 plus 3, what's its conjugate? Plus root 2 plus 3. What's the rule that I'm using here to get the conjugate? I'm changing the sign on the root. That's what the rule is. So what's the conjugate of 2? 2. And the conjugate of root 3? Minus root 3. Okay, I'm changing the sign on the root. This is called the conjugate. I'm sure some of you have seen this before. Yeah. So, in general, the idea is A plus root B root C, its conjugate is A minus B root C. That's its conjugate. And the conjugate will be useful now if I go back to the example I'm doing. So, back here, I'm sure some of you have seen this before. The trick to solving this problem is you multiply by 1. And in this case, a very special type of 1. You multiply by the conjugate. Minus 7 plus root 14 minus 7 plus root 14. Now when you think about it, you're multiplying by the number 1. So the value hasn't changed. But doing this trick will actually simplify it. Let's see what happens. Oh, actually, before I start, I need to do something with this. 504 will be 126 and 4? Is that right?
Yeah.
Yeah, but is this one right? Actually, what am I doing? I have a calculator right here. 126 times 4. Yeah. Okay, and that will be 2 and 2. And that will be 6 and 21. Which is 3 and 7. Which is 3 and 2. Which is 2 and 2. Goodness sake. So root 504 will be 6 root 14. Let's test it out. Great, wonderful, wonderful. So, let's go back to the question here. Minus 63 plus 6 root 14 over minus 7 minus root 14 times minus 7 plus root 14 over minus 7 plus root 14. And then we multiply. So, let's multiply the top. Minus 63 times minus 7. 4, 4, 1. Minus 63 root 14. Minus 42 root 14. Plus 6 root 4. No. 6 times 14. 84? Plus 84. Now let's multiply at the bottom. Minus 7 by minus 7? 49. Minus 7 by root 14? Minus 7 root 14. Minus root 14 by minus 7? Plus 7 root 14. Minus root 14 by root 14 is 14. Now look at what happened. Look at this. This was not an accident. This should always happen. These middle two guys should cancel. Minus and a plus. So on the denominator you're left with 35. And on the top you have 441 plus 84. 525 minus 105 root 14. Or, as it's usually written, 525 over 35 minus 105 over 35 root 14, which I think can be simplified.
Yeah, so it's the 5.
15? And 3. There's the answer. Is that hard? So we'll definitely do another example. I'll give you one to try first. Yeah.
I remember we took back in high school when we were talking about factoring, we took that a plus b multiplied by a minus b is equal to a squared minus b squared.
Correct.
I think isn't that
It's a similar idea, yeah. Yeah, it's like the difference of two squares.
Yeah, exactly. So couldn't you just like automatically or
Yeah, you could.
just
No problem.
But does that mean that the minus or does that mean you also have when multiplying by the conjugate, does that always mean that the sign of the radical has to change?
Yeah. Yeah.
You can do it without. It would still be squared.
Yeah, but you should always end up like with a number minus a number.
Yeah, you could do that if you without if you took the minus to the other side, the same thing. If you take the minus on the whole number instead of the radical.
I have no idea what you're asking me, but I feel like the answer is yes.
I'll come to you after. No.
If necessary, but I think whatever you're asking me, I feel like it's a yes. So your answer is yes. Okay, let's try another one. I'll let you try it first. Let's say minus 99 plus root 50 over 13 minus root 162. Okay, simplify that for me, please, and then I'll show you the answer. Okay, let's start having a look at this, or get a start on it. Let me just do my workings here. 50, 5 and 10, and 5 and 2, so that'd be 5 root 2, 162, 8 and 21.
Yeah, exactly. That's exactly how that's.
Double check it. Nine root 2. Oh. Oh yeah, that's not 8.
Do 6 and 27.
81, yeah. 3 and 27. 3 and 9, which is 3 and 3. 3, 3, 9, 9, 9 root 2. 9 root 2. Let's check that. Great, 9 root 2. Okay, let's have a look here. So this is minus 99 plus 5 root 2 over 13 minus 9 root 2 times 13 plus 9 root 2 over 13 plus 9 root 2. 99 times 13 is a big number. What big number is that? Minus 1287. Oh, why am I doing this? 991? Is the next one 991?
No, 891.
No, what is it?
No, 891 after I just took the one down to the denominator.
891. 891 root 2 plus 65 root 2? 2 times, 90. And then this will be 13. Are you giving me the final answer? Oh, sorry, yeah. 169, and then you'll have a plus and a minus piece that will cancel in the middle. And you'll have here minus 9 times 9 is 81, 162. Yeah. So on the top, goodness. 1287 plus 90 minus 1197. Okay, and then what's the next one? Okay, over. And does 7 divide into both those numbers?
Yeah.
It does. So really? That's strange, but it does go into both? Well, 171 for the first one. And 108 for the second one? For the second one then? Yeah, okay. Alright, it's tricky. In the exam, the most common questions I see them ask you to do is to multiply 2 surds or divide 2 surds. About 50-50. Yeah. We wrote this down if we need it. Yeah. Guys, does everyone have this written down? Yeah. Okay. So what I want you to do for a few minutes, just for 5, maybe 10 minutes max, You can get a start on your homework from this. So I think again what I'll have you do is the first and the last in each question. So AZ, 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 AY. First and last in each question. Try these now for a few minutes. Make sure you got an understanding here.